We will kick off with a linear reservoir system of one directional flow in the x-axis. The control volume of this system is highlighted in blue color. The whole system is having a uniform thickness. By applying the principle of conservation of mass, the mass of fluid flowing in minus the mass of fluid flowing out is equal to the mass of fluid accumulated in the control volume. Now let us define the formula of mass by knowing the mass flow rate is equal to volumetric flow rate multiplied with density, and we know that Q is equal to area times velocity. So we can substitute Q and move T from left to right. Here we got the formula for mass. Here we are trying to derive the mass of fluid flowing in. We add the position which x plus delta x to the mass formula. Obviously area is width times height. Easily we substitute, rearrange, and that's it. For mass flowing out, we apply the same theory by adding the position which is x. Area is still width times height, and there we go. Mass accumulation is basically the difference in volume multiplies with total fluid density. The reason why porosity is involved is simply because we are going to know the fluid density alone, where total density multiplies porosity equals to fluid density. Bam! Volume is substituted with width times height times length. The final equation is then put together to form mass conservation formula. We will then divide the whole equation by width, height, difference in time, and length. Are you bored? If yes, then you're about to sleep in a while. But sleep is only for losers. The equation then we have gotten will then be further simplified by limiting the equation twice, where delta x approaching 0 and delta t approaching 0. Here you have the equation for continuity equation. This lorry here will now bring us to transport equation, where it is driven by a man commonly known as Darcy. Darcy law is famous among us. Reason why 5.615 is multiplied is because we want to convert it to unit barrel per day. Q is equals to V times A. So when you rearrange, it becomes V equals to Q over A. By moving A to left and substitute it with V, we have transport equation. Transport equation is substituted in our continuity equation. The right side of this equation is differentiated using product rule. How to use product rule? There are two unknowns, so we keep one, differentiate the other, plus keep the other one and differentiate the other. Chain rule is applied on delta phi over delta t. The solution then is substituted in. Wait, did we forget compressibility of rock and fluid? Rock compressibility involves with porosity, thus the formula of rock compressibility is substituted in the equation. Let's assume that we have slightly compressible fluid, which directly links to homogeneous reservoir with constant permeability and fluid viscosity. That means we don't have to differentiate them and we bring them out. Using the product rule, we differentiate the rest, and this is the outcome. Substitute it into the original equation. Moving on, we differentiate density in terms of x and t using chain rule, and then fit it back into the equation. Now density is too mainstream, so we cancel them out by dividing itself. This is where fluid compressibility comes in action. This is the formula of C, fluid compressibility. Fluid compressibility is then substituted twice in the equation. We neglect the whole term as it is very small. The equation is further simplified, and as you can see, there's rock compressibility and fluid compressibility on the right side of the equation that leads to total compressibility CT. Equation is rearranged, and finally we've got the diffusivity equation, one in terms of days and the other in